Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Akeela Tyan in the class of 10E in Manisan Jaya Kota Batam. Today I will tell you guys how to solve Chemistry Paper 1, Paper 2, Cambridge in the code 9701. And for today, I'll be telling you guys how to solve this question in maybe an easy way. I hope you guys understand. So let's start. So first question is, which molecule has an equal number of bonding electron and lone electron? Well, I'll be making this fast, which is I'm going to be answering B. Why? So we could see here at the bonding between the carbon and the oxygen, which is COO here, we can see the oxygen have two lone pair for each oxygen, which is make it as four lone pair, and the carbon and oxygen have each bonding have two bonding electron, which is making it 1, 2, 3, 4 bonding electron and 1, 2, 3, 4 electron, which is has an equal number of bonding electron and lone pair electron, making it the answer as B right here. Okay, next is we have another question, which is the volume of sample of methane is measured at a temperature of 60 Celsius and a pressure of 100 kPa. Well, what the question is, what the mass of sample of methane? As you guys know, to find a gram right here, we use these equations, right? This is the question. Oh, I'm sorry if my writing were bad, but this is the equation, by the way, right here. And here's how to solve them. So first we find the mole. We find the mole by using these, because yes, of course, we want to use these equation right here, which is the n equals to gram per mr, which is there is a gram there. So if you want to find gram, we could actually use that equation. But to actually use that equation, we need to find the mole, which is from this equation. From this question, we don't have the mole, so but we could find the mole by using PV and RT right here. So we make n equals to PV RT. I'm sorry if my writing were bad. Right here, PV per RT, which is here we put the pressure. You can see pressure here is 100 kPa, which is 100 K makes it 100,000 right here. And the volume is measured here. Ta-da. And then and then the R is constant, which is we actually always use 8.31. And then for the temperature, why suddenly is 330 3, which is we could see here is 60, right? Wait, oh, I'm sorry, I'm changing the color, by the way. I'm changing into red. So wait, purple. So to find the temperature, we need to put 60 plus 270K, making it at 330 here. And then we find them all by calculating them by times and then divided by the RT. And then we find them all in here. Here, and then of course to find the mass we use use the n equals gram per mr, which is how to find the mr. If you know, methane is JCH4, so this mr is 16. You can actually find it in the periodic table, and which is a 16, so we just times the mole for to the mr, making the answer is 3.2 gram, making the answer is C. Yay. Okay, next question. A 200 centimeter cubic sample of water has a non of oxygen gas dissolved. Okay, so the question is, what is the concentration of the oxygen gas in the water? Here's how to answer it. Of course, we need to find the mole. Everything. Yep, you know the equation, which is n equals to um, mo- mm, concentration times volume. This is the equation. So to find the find the concentration, we just put like this. So C is I actually use the concentration as M, but the M capital M. But I'm sorry, I actually write it as not capital M. And this is the equation if you want to find the concentration. But you can see here to find the concentration, we need to find mole and volume, which is we actually had the volume already, which is what? While we don't have the mole, right? We don't have the mole. So here is it. So this is the amount of oxygen. Of course, we use the equation like the last time. PV equals RT. Same as it, you guys just use N equals to PV per RT. Of course, to R constant, you know how to find the Celsius, yes. 35 plus 273 equals to 308 Kelvin. And then Kelvin. And then for the pressure, here we have 1 times 10 to the power 5 pressure. And then for the volume, we could use the gas. Okay, we use the gas because use the gas. And of course, here is centimeter cubic, while the ideal and the answer is dm. We we change it to dm, which is it times by 2 10 to the power 2, and then times it again to the power of minus 2, and then times it again with 10 to the power of 3, making it as 10 to the power of minus 6 right here. And of course, we already oh what is these? I'm sorry, guys. I'm sorry. I'll delete it later. Check, check, check. Yes. Here, and then we found the mole, which is this is the mole of it, and then we just put into the equation right here, and then use the volume of water because we know the volume of water is here, and make sure to make it as a dm cubic right here. Make sure to use that, and then we got the answer right here. So making the answer is B. Okay. Next question. A student performed an experiment to measure the enthalpy of combustion of ethane. This is enthalpy. So let's have to actually find this. Here is it. Actually, you don't need. Sometimes you actually doesn't need this equation. It depends on the question sometimes, and we actually know in here 140 kg right here, which is this is the final answer, but we don't know the enthalpy of ethane. But we know the equation to find ethane is carbon plus hydrogen, and in here the hydrogen we times it by 2, and then the hydrogen. Oh, I'm sorry, the hydrogen is supposed to be times by 3, and the carbon is times by 2. Making it the carbon into minus 788, while the hydrogen make it as 858, and we just bash it together because actually minus minus making it as minus 646, and we don't know the ethane, so we just um we just change this right here. Yeah. Because yeah, Bracton minus product. So yeah, we just changed the ethane to here, and 140 kg to here, and if you know like different position, the minus in turn to plus. So 164 equals to 156 kg, which is make the answer is B. Oh. Okay, next question. Carbon monoxide and methanol can react together to form ethanoic acid, which is here we could see. Yes, this is the CO. This is quite easy, guys. All you have to do is, ta-da! All you have to do is just here we found this 283. Wait, I'm sorry, guys. Just this minus 726, making it as minus 109, and then this one, the ethanoic acid, is minus 874.1. And then since we know like here the previous one like this, we just do this to find the delta H, which is the enthalpy, which is the is minus, right? Minus, meet minus and make it to plus, minus 1009 9 plus 874.1 makes it, the answer is 100 1000 130 minus 134.9, make it, the answer is B. Next, this is another enthalpy. You guys can see this is the change of combustion right here. This is what we got from the question, and then the final answer is this. But this, you guys have to see, he used an incorrect value for the standard enthalpy change of combustion, and then he changed into a correct one, into the final answer is this. So all we need to do is to find a standard enthalpy change of combustion of carbon. So this is how we do it again. So this is the equation for to find enthalpy, enthalpy of what is this, ethane, right? And here we could see is hydrogen here. So yep, of course, 3 times 286 from here, right? Which is make it the answer into here, right there. And then we know the what's that? The ethane, which is minus 1560 right here. And then this is the 2x. This is the product, this is the reactant. Since the product and the reactant, since we don't know the 2x, and we see this is a carbon, we don't know the carbon enthalpy, but we know the final answer is minus. So we just do this, this is plus, guys, because this minus meet minus, make it as a plus. So minus 858 plus 1360, make it as 702. And then yep, we just put here, just put the position into there, so they could actually get the result for the 2x, which is here, minus 158 minus 702 equals 2x. We could see the x in turns to here. Yeah, this is how to find it. Just divide it by 2, and then making the answer is C. Let's go. Okay, next question is, this is quite easy, no need to think a lot, just calculating this. Duh. Okay, let's start from here, from the left one. So C bonding right here, we could see this is have 2 bonding right here and then here, so making it 2 times C, 2 bond of CH, and then we know the CH is 410, just times it into turn to 820, and C, and there is only one triple bond, C triple bond C, and which is, we just know it's 840, just put it here, and then double bond of oxygen, which is 2.5, because we can see here. This is an oxygen. Wait, I'm sorry, guys. Here. Here. So what is 2.5? Maybe a lot of you guys have been answering it. So 1 per 2 equals to 0.5. So yeah, 2 plus 0.5 is 205. 2 plus 0.5 is 205, and we just calculated them because we know here on the double bone is 496. We just calculated them and just got this answer. And then the total is 290 kg more. So now we go to the, okay, let's just change the color into the red one so I could show you. This is, okay, let's do the right one. So we see here, okay, right here. Oh, just only until the H. Okay, sorry. H2O plus 2 double bone 2 COC. Okay, from there we know H2O doesn't have double bone. It just only H bonding with 0, making it two bone of oxygen and hydrogen, and we know oxygen and hydrogen is 460. Okay, then 920, and then C carbon dioxide right here, and CO2. Oh, I'm sorry, CO2. Right, as you could see from the, from the previous questions, the first one, we could see it's double bone. So yep, and since it's double bone, and we have two of C and double bone O, and it's actually have the coefficient of 2, making it we have to times it by 2 again, making it as 4. And then this is the answer, and this is the 300 total of this one here to this. And then yep, you just do this. This is the enthalpy: energy in, energy out. Make it to 2,900 minus 388, making it as minus 9080, which is the answer is A. Yeah. Okay. This is pretty interesting question. Maybe a lot of you guys might be answering this because positive, yes, of course. Negative. Actually, the answer is this is nope. The answer is A. Why? Why is A? Because first of all, we know there is intermediate. Oh wait, what is intermediate? So this is I put here for you guys in case you guys are actually use of intermediate. So an intermediate is a temporary stop where you stay for a short time. So because there's no way from this compound just suddenly transition to Z. No, we need like a stop, a temporary stop, and then it actually do a transition again to Z. So yep, making this the answer is correct. Why the other answer is correct? Yeah, because this is the correct one because there's the intermediate, and this is you can see here, and give you the y must be higher than this x. Correct. This one incorrect. This one is correct, but no intermediate there, and then the must be lower than the y, and it's quite same level, which is not really. So the answer is A. Okay, another question. Sulfur trioxide. This is sulfur dioxide and oxygen. Which one is the correct answer? Let's check. Okay, this is just doing manipulate. I'll be showing you guys. I'm just putting here because I'll be doing scribble for you guys. Okay, so we could see here. This is 2SO2. SO2. Because we know the coefficient is 2, we times it by 2 because the SO is 2. While the this equation right here don't have SO2. Okay. And it's on the left. So we turn this into a plus. So plus 296.8. Okay. And it's actually still constant between this, right? So we make it the question. Okay, I'll just go to S. I'll put it here. Okay. I'm sorry, my script was bad. 202. Right. Um, this one we could actually diet push this one. Only left it us with the 2SO2, this one, and the is 1 mole of oxygen, while this one's still constant because there actually doesn't have, yeah. And then, all right, we just, we know this is times by 2, right? This times by 2 is 8. If this is, I'm sorry, 593.6. And it's turned to plus because we actually do opposite up direction, which just make it this and plus. And then here's the equation. And this is the equation right here. Plus, make minus, and make it as this. Make it the answer is the, yeah. Okay. Another question. Okay, I think this is quite tricky, but let's see. Okay, next question. The enthalpy change for neutralization. Yep, this one. By the way, to make to find the temperature, we know if there is like this kind of number, we know it's going to lead us to enthalpy or Q equals to mg delta T, mc delta T. Okay, so yes, before we actually find the delta T, we already know the mass or the volume, which is the mass actually here 30 plus 20. If you guys questioning about why suddenly it's turned to 50, guys, try search on Google 50 centimeter cubic into mass. You'll find it as 50 gram. Yeah, if not 50 gram, I forgot, but it's gram things, okay? And then, okay, but of course, but we don't know the Q. How are we supposed to find the delta T? Huh? Right? How are we supposed to find the delta T if we don't know the Q? That's why. And here we already have the what's the name this is the enthalpy, and we to find enthalpy we just use Q per N. And then how to find the Q? We just, yes, we need to make the equation like this. Just, why the mole suddenly 0.06 right here, okay? This is the react of 1.1 ratio. Times this to find the mole. And why we only use 0.6 mole? Because this one excess and then this is 1.1 ratio. So the HNO3 is excess of 0.02 mole. And then we use that, and then we use this equation here, and then we times it and make it as this is as the answer. And then, yep, to find the delta T, we make this as an equation. And then, yep, as I do it like this, the Q is this 3,420 joule, while the mass is 50, as I tell before. 4.2, this is same like a constant number. Make it the delta T is here. Delta T, which is final initial. So to find the final minus initial, to find the the final, use this. Okay, you know how to do that. You guys smart, kan? I mean, you just put 25 plus 16.3, making the answer is a 41.3. Yeah. Okay. Another interesting question. Okay. Okay. How to do this? We know glucose equals to this, ethanol equals to this, okay? And how we know this is glucose? Glucose, this is here. Glucose is C6H hydrogen 12 oxygen 6, which is only one, making it this is only one right here. Well, if you see the ethanol is minus 1,368, but this coefficient is 2. So times it by 2, okay? Here, already times it. But product product minus rent, right? Product minus rectant, which is rectant minus productant. Sorry, which is making it. This is as plus right here, and then we just got the answer. This is same as the question before. So I hope you guys really understand by me. Okay. Next, acting as a base, underline. Okay, I'm sorry. This is supposed to be underline, but I don't know. I think it's gone right here. In which direction is the underline? I'm sorry, I put the right word. Acting as a base. Okay, I'll be fast. I'll just choose one. Do C as the answer. Why? It's Scrabble. Yep, it's Scrabble. But you guys see here, this is supposed to be the product. So you can see here, this H right here is actually getting H from here. So it gives H here. So this is act as a base. And that's why it turns to H2O. This is why it turns to this, okay? This two thing is supposed to be turned like this. Okay? So it's just Scrabble. You just like scrabbling again and then here. So that's why it make you confused. But this thing is actually H2C03 Z oxygen 3. Okay? That's why you could see the H got another H from the H and O2, making it as a base, while the HNO2 is acting as an acid. So the answer is, of course, C. Okay, I'm sorry. I don't have the document file, so I will be showing you guys this. Okay, this is quite interesting because from here, we could see right here, this strong, this too strong. But why the answer I put is C? Why not A? Well, this one too is, yeah, there is one of them is weak. While we want to neutralize, we need to actually uh we have to yeah, we want to, we need to strong. Here's the why that is. So as you know, each of the Q and P has 200 centimeter cubic, while here this is a lot of people was wrong. Only Q need to be 10. Okay, need to be 10. Well, this is 20. And here from the answer, we could see the OH actually have 2, which is each of OH2 include for 10 of the volume. Okay, 10 of the volume of his of the 10 centimeter cubic. And why the answer is not H? The answer is not A because the natrium OH is full of 20, while the C is actually 10, making it correct for the graphic, which is hit on the 10, making it like close. Yes, that. So yep, that's why the answer is C, not A. Don't be don't be go check. Okay, next is sulfur dioxide. Okay, which statement about these two reactions is correct? Like, ta-da! When looking at the first reaction from right to left, here, HSO minus 3 act as a base. Yes. Why? Why acting as a base? Because yeah, it get here. And then yeah, it's supposed to be H2SO3, but it's misahin again because it want to be a water, so it turns to H2O and then it get SO2. This is a good correction. And from here, same. It want to be alone. This want to be alone. And you just here making it 2H. That's why from this direction, HSO minus 3 is always acting as a base. So yeah, the answer is A. Hmm, 39. Okay, this is same. Let's see. Okay, let's just get into it. The answer is C. Yep, C. Why? Same as before. This is Scrabble, scatter. Not supposed to be scatter. This goes here. This is the HNO2 is acting as an exit acid, while the HCO3 is acting as a base, making it scattered here. It's supposed to be H2CO3, but it's scattered to H2O plus CO2, which is, yeah, that's the answer C. Paper two. Maybe a lot of you guys been actually waiting for a paper two question. So here's how to answer a paper two question. First of all, okay, how to do this? Ta-da! Wait! Suddenly there is sir. Electron is negative. Negative wants to be with positive, same as boy. Boy wants to be with girl, so that's why electron pick the girl, which is positive. Proton is a plus, and of course, she choose her guy, which is negative. This is same like proton as a guy and then electron as a girl, choosing their partner, of course, different gender, okay? Like that. And wait a minute. On the second question, there on the diagram, draw a line to show and separate. Neutron. Neutron is neutral, which is she want to be single. No need to do positive or negative. Just single. No job. So just draw the line right here. Ta-da! That is neutron. And then the second answer, the second question B. Electron is atom up to 36 km. Okay. I already make for you guys here, right here. 1s2, 2s2, 2p6, 3s2, tp6, 4s2, 3d10, 4p6. Okay. Number of orbital. So what is number of orbital? This is already give you some, this is the 1s, by the way. So 2s same. 1s, 2s, 3s, 4s the same, which is making the orbital, since it's actually have four of level, making the s is 4. Wait, why the p is not? Wait a second. You see, if p, the box is making as 3. Since the p have three, like 1, 2, 3 of level, we just times it by 3, making 3 box times 3 equals to 9. The d. Why the d is only 5? Okay, so for d, it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And yep, it only have one level on the tree, which is, yeah, it's only 5. 5 of each box. 5 box. So yep, that's the answer. Which is the answer is 4, 9, 5. Or 4 is for the S, 9 for the P, and 5 for the D. Wait, okay, next. The diagram draw a type of orbital. This orbital is p orbital. Yay! Okay, so state the number that exists on this type in atom. So we need to find the number of electron in the level of p. Okay, since we know this drawing is p and there is only one p on the 9f, which is 2p5, making the electron only 5, sadly. So each box have 1. So each box have 2 and one box has 1. So making the electron only 5. Okay, so just check this number, okay, to put on there. Next, complete the full electronic configuration of chromium. Yep, you know how to this RR is RR is RR is 18, while the chromium is 24. Right there. It says here RS is 18, so we just make the config until 18, which is 2 plus 2, 4 plus 6, 10 plus 2 again, 12. How to make this? It's just from the electronic configuration, which is 1, 1, 2, P, this, and then, yeah, just followed by the electron right there. That's how you do it, okay? Yeah. So this is the full electronic configuration of chromium. Okay. This is quite hard and this is tricky. You think you use all of these abundance? No, it's only need AR. Oh wait, no, no, no. Iridium. Wait. Oh, I need eraser. Oh no, no, no. It's not erase. Uh, uh, only need iridium, which is only two boxes here. Okay, let's start. It's pretty easy. No need tricky thing. Just total abundance, which is 15.18 time plus 34.82, making it 50. And we just make it like this. I start topic mass and abundance. Just times it by this. And then we could found the RR, which is the total RR is this 192.3528, but it's only two decimal place, so just just until the five. I'm sorry, I just until the five lah. Or we can just actually make it as 100 1.92 times 10 to the power of 2. Define relative atomic mass and then another abundance. Okay, here. This is the defined relative atomic mass, average of one atom of an element taking into account all its naturally occurring isotope. Relative. Remember, this is the keyword. 1/12 the mass of atom of carbon. This is the keyword, okay? For relative atomic mass, there's supposed to be this in your definition, okay? And then this is the other question. So yeah, we need to find the third isotopic number of iron. So how to do it? How to do it? Very easy. First 50.8. There's no in here then. Found in periodic table. Use it as in your AR because that's the average AR we actually use every day. And then we put this. We just times these, right? Times this one, and then because there is third and we want to find the isotopic mass the third one, use X as the symbol, and then how to find the total, the appearance. This is 100 minus 9.19 minus 6, making it only left of 2.1. Okay, and then we got the answer like this. Yes, this is already put there for you. 2.1x equals to 119.39, making the x is only this. Yay! Finally, this is the isotopic mass. This question. Next, deduce the number of pair electron in the 3D subshell in iron 2. One pair. Why? So, 3D subshell, which is 4 box, right? Five box, and only two pair. Yeah, this is already draw it for you. I already say each box have one electron, but only one box has another one electron, make it them a pair. We just found this on the as the periodic table, which is just find the 3D subshell, which is use electronic configuration again. Okay, guys, remember use electronic configuration to found like these pair of electron, anything electron. Find the use the electronic configuration. That's what Helen told me, guys. So make sure to follow her rules thing. And then sketch the shape of the lowest energy orbital in the shell with principal quantum number. So 2s and 2p, right? The n is 2s and 2p. Only there. There's no 2D. No. Only 2s and 2p. Since the 2s has lower energy than 2p, which is we know as a spherical. So the shape is only spherical. No need like wow, no need, just spherical because it's if P means two, but since P is low, just take one pole. Define enthalpy change of formation. One mole of substance is formed from its element in their standard state. what is this? I'll make like this. For, I know, like this one, like O2 and then plus maybe C, making it as CO. So that's why 1 mole of substance is from element in the standard rate. This is the 1 mole standard state. This is the standard state. Next question. Okay, this is same as I do before. This is formation, right? Formation. I don't know if it's formation or not, but it's actually formation. Okay, this is how to get these 2F plus 3 per 2. Oxygen cannot stand alone. Need different another O. So that's why if you want 3 oxygen, make sure to use and fraction and proper fraction that one. And then use the CO of this one. And then how to find the enthalpy. This is the equation. Remember, if you want to find the enthalpy for this, make sure you make the equation correct. Yeah? Make sure the equation correct. Okay. Okay, since we know this one only one, so we just times it, right? Oh my god. Okay. Enthalpy change. Enthalpy change. Okay. This is the equation. This is first for these one. Oh my god. There is no 2FE. Okay. Okay, we do on the right one first in here. Wait, let me erase it because it's quite confusing. Which is this is the 2FE and a 3CO. We know CO here, CO2 right here. Just times it by 3. And then we got minus 1180.5 kg more. While the left one is just standard, except the CO. We just times it by 3 again. And then do the delta H, which is the product minus the reactant. Eh, No, then this is it. This is the product right here. This is the reactant. So yeah, product minus reactant, and make it as a plus right here because minus is plus. And then yep, we got these, and then just minus it, and then this is the this is the answer, everybody. Make sure you guys got it correct. Okay, I think this is the last question from me, which is ta-da! It's very easy to say. No need thinking a lot. I think quite need to think a lot because you still need to make an equation. Here's the question. 2NH3 plus 3Cl2 makes it as N2 plus C hydrochloride. Okay. Since we only know two of the compound, which is the HCl and the NH3, making it as this. So the NH3, we times it by 2, while the HL is we times it by 6. And then product minus reactant, minus 552 minus meet another minus, which is make it as a plus again. Make it this is the answer. Thank you. Oh my god. Finally, you guys actually been here with me. This has been 40 minutes, I think. Since my recording is 40 minutes. Well, I hope you guys understand. I'm sorry if my explanation wasn't really that clear because I'm still a student here trying to teach you guys how to do chemistry. And I hope you guys do well on your CIE test, maybe in winter or summer. You know, same code as me. I heard that Singaporean already done that. Well, congratulations if you guys pass your AS or A level. Well, I think that's all from me. Thank you for watching and see you.